All right, so our next concept we'll be looking at are angle properties of polygons. So just to reiterate, or to maybe review what a polygon is, it would be any kind of shape, so it's just meaning many shapes, right? So I have a few listed here. So triangle, quadrilateral, pentagon, hexagon, heptagon, octagon's another popular one, and you'll see some other shapes. There's actually a formula that helps us out to actually solve some of the measures and the angle measures, the interior angle measures and the exterior angle measures, which I'll talk to you about here. This is kind of giving us a background of the formula. So what the formula in question is this one, which we do have a formula sheet for this course, and this is on it. So on the formula sheet, you would see the sum of the measures of the interior angles, and this formula would be there. There's also a secondary one right beneath it. Is this one. So usually I'll just use the first one on the top, and then it's actually a pretty straightforward formula once you get to know what it means. Then there's also this second one. The second one on here is measuring each interior angle of a shape of a polygon. So these are the two formulas we'll be working with, and really they're the same thing. N is indicating the number of sides of the shape, right? So for example, if it's a triangle, you throw a 3 in for N and then multiply. So, and I did actually, on the note sheet, you'll see I kind of meshed in the number of sides with the shape into one column, into one little category. So a triangle, we all know that there's 3 sides in a triangle, right? The number of triangles in a triangle is 1 triangle, right? And the sum of the angle measures, and we talked about this in the last video. All angles added up together in a triangle will give us 180 degrees. So this is review from the last section, that line anyway, right? Right, so, but as we keep going, a quadrilateral has 4 sides, right? Quad. Now, number of triangles, you might be thinking, well, what do you mean number of triangles in a quadrilateral? But if we just drew a quadrilateral, just a little one right here, a little square or a rectangle, right? A 4-sided shape. So that would be your squares, rectangles. You have different shapes like rhombus, which is a square that's sort of off kilter a little bit. Rhombus, parallelogram, diamond. Those are all, I'm sure there's some, trapezoid, right? That's another quadrilateral. I mean, you might have came across some of those before. But the number of triangles in a quadrilateral would be 2. If I drew a line there, see how there's 2 triangles in there? So there's actually 2 triangles in a quadrilateral. So that means then I'd have 180 with another 180, right? Which would give me 360 degrees. Which you probably know that too, right? 360 degrees in a quadrilateral. So those top 2 lines probably aren't too crazy for you. We'll get into some with a few more sides. So a pentagon has 5 sides, right? Now, number of triangles might be a little bit more, well, I'm not sure how many are in there. After this, you might sort of see a bit of a pattern. If I drew a pentagon, a 5-sided shape, like so, right? How many triangles can I pull out of that? So, let's see. There's a triangle. If I drew 2 lines there, see? Triangle, triangle, triangle. So there's actually 3 triangles in a pentagon. So that would be 180 times 3, right? Because there's 180 degrees per triangle, right? So 540, right? And now you might be seeing a bit of a pattern here, which actually, if you do, that's great. Notice how there's a gap of 2 between each. Remember the formula? N minus 2, right? So the number of sides, take away 2, will give you the number of triangles. Then you just multiply that by 180, right? So a hexagon, for example, has 6 sides. If we take away 2, we get 4. Multiply that by 180. We get our answer hexagon is 720. So So really you're using the formula without writing the formula down, right? Hectagon has 7 sides. Take away 2 is 5. And then 5 times 180 is 900. Right? Oh, 900, not 90. And these are all degrees, by the way. There you go. Now, if I wanted to do that same thing with a formula, which is kind of what we're doing here, we're just doing in a table. Really, you're using the formula. So if I take the formula, I didn't have room to put the octagon on here, but let's use the formula with an octagon. So I would just go 180 bracket 8 minus 2. Kind of what we're doing here, right? Because notice again how there's all gaps of 2. Number of sides take away 2 gives us the number of triangles. Then we multiply that by 180. So 180. So that would be 180 times 6, right? 6 triangles in a this would be an octagon. Right, octagon, like a stop sign, right? Right, 180 times 6. That would give us 1,620 degrees. 1,620 degrees. So that's the sum of the measures of the interior angles. So what that means is if I add up all the angles within my shape, within my polygon, in this case this here is an octagon, all the angles would add up to 1,620 degrees. All of them together. The interior ones. Right? So this will be one type of question that you'll have to do. So yeah, and we could, well, we have all the rest of them there. Like even if I reiterated hexagon, say. So if we wanted to just prove that with the formula, well, let's just try the hexagon one with the formula. I'm just going to throw a 6-sided shape in here, right? So 6 take away 2 is 4. If you just go 180 take away 4, remember the 4, right? So that gives us 720, right? So you just need to use this formula if you're asked to find the sum of the measures of the interior angles. It sounds really funny and kind of tongue twister like, but that's what this is, using this formula. Okay? All right, so we'll try a different shape. We'll try a larger one. So sometimes they'll give us pictures, or sometimes they'll just say with a X amount of sided shape. This is such and such. So there's an image in your textbook that I'm going to point out to you on page 97, just to get a little bit of a different sort of style. In case you don't have your textbook, I'll just show you the image. So see that polygon right there? So that one, the one in the blue under your turn. So this is on page 97 if you have a textbook. So it says, determine the measure of each interior angle of a regular 15-sided polygon. And they're calling it a pentadecagon. You don't need to memorize that, right? They're going to tell you. They might throw some crazy words at you, but there's the shape. And they tell us it's 15. Sometimes they'll say, here you go, here's the shape, and you need to count. If you have to count, I would just put a little pencil mark where you started as 1, and then so you know where to stop, right? So you will probably see some of those where you have to count them yourself. But they're telling us it's 15, so we don't need to worry about it. So 15, so I would just take my formula. So the sum of the measures of the interior angles is like so. So here's my formula. Now the question's asking, determine the measure of each interior angle of a regular sided polygon. So this is going to find each interior. So it's a 15-sided shape. So all I need to know is how many sides there are. I don't need to know the name of it. I just threw the name in there for interest's sake. Right, so there it is. So then I've got 180 multiplied by 13. That should give you 2,340 degrees. 2,340 degrees. So this number right here is the sum of the measures of the interior angles. Of the interior angles. You'll have to know the difference. There's actually 2 other answers I'm going to bring you to. So this one here is the sum of the measures of the interior angle. So that's all of the angles added up inside the shape, inside the polygon. The question's actually asking, determine the measure of each interior angle. So if we're looking for just one angle, you would just then divide it by however many sides you had in the shape. So if I take this, divide that by 15, that gives me 156 degrees. Whoop, missed 5 there. 156 degrees. So this would be each interior angle. Right over, well, yeah, right here. Each interior angle. So you're just going to divide by n, which was the second formula that I mentioned. It was 180 times n minus 2 over n. You could just plug that right in your calculator. So all the angles together, each individual angle. The other style of question that you'll see, and it's not what this one's asking for, is to determine the measure of each exterior angle. So let's just do that one, just so you... I'll just put it here. Should have made myself a bit more room. So if you had to figure out each exterior angle, so what that means is, with my shape, I realize I'm not drawing a stop sign there. So this is an octagon, but I'll draw you what an exterior means. So each interior would be here, of course. That's an interior angle. If you had to figure out the exterior angle, it's this. Exterior angle in terms of 180 degrees, so it would be that. I've had some debates about this in some prior classes, but this is how this textbook asks it and how this course treats it, is just drawing a line off of it and then measuring that. Exterior, in a lot of cases, is from here to here, measuring that whole piece. But for the purposes of this course, in like your exit exam in this course, I'd be measuring right here, the straight line off it. So you're just then going to subtract 180, take away your total right there. So 180 take away 156, right? And again, this is an octagon, it's not a pentadecagon, so don't put that on there. So that would be 24 degrees for this particular question. So this is each exterior angle. Remember, it's off a straight line, off a 180 degree line, then you have to measure it, not the full circle, not a 360. Okay, so that's the important bits from 2.4. I just wanted to introduce that formula to you, this one right here. So try some practice questions to get to know it and to understand it. The practice questions, I'll write on my little whiteboard. So again, this is 2.4. Page 99, and it's number 1, 6, 7, 8, and 11. So give these ones a try. If you get through those, and again, they start a little more basic and they progress to a little bit more difficulty. So give those a try. If there's any concerns with any of them, we can talk about them together. Either together or on Moodle. We can have discussions as well. But let me know. And again, that is characteristics of polygons. The last thing we will talk about in this chapter will be congruent triangles, which will be our next probably 2 videos.